Hello, this is Ms. Moore, and today during chemistry, we're going to talk about naming ions and ionic compounds. Today's essential question: how are ionic compounds named? All right, we're going to start with the cations. So naming cations. And we're going to start with not only naming cations, but naming cations coming from groups 1A, 2A, and 3A. So real quick review, remember that cations are the metals, and they have a positive charge. All right, so again, there are two different rules for naming cations. So we're starting with the cations coming from groups 1A, 2A, and the metals in group 3A. So these are super easy to name. So cations get their name from the elements from which they were formed. I mean, that's really it. So for example, K plus is the potassium ion, and K is the potassium element or atom. So if I wanted to know the name of, say, for example, Mg2 plus, that's a cation, I would find Mg on the periodic table, see its name is magnesium, and I would just call this the magnesium ion. So really you're just looking the name up on the periodic table. And again, though, we're talking about only cations coming from groups 1A, 2A, and 3A. So that's not too difficult. Let's move on to naming metal cations coming from groups 3 through 12 and 14 through 16. I actually like to think of this easier as metal cations coming from groups not 1A, 2A, or 3A. Okay, so basically we're now talking about all of these, the transition metals, as well as these right here. Okay, so the naming rules for these guys is a little bit different. And let me explain to you why. Cations formed from these metals do not become like noble gases. It's kind of sad because they'd have to lose too many electrons. All they can do is become closer to noble. And so what we need to do when we name them is we need to somehow denote what kind of charge they have. So how do we do that? When an element forms two or more different types of ions, they are distinguished by Roman numerals. So for example, Cu1 plus is going to be the copper Roman numeral 1 ion. Cu2 plus is going to be the copper Roman numeral 2 ion, and I bet you can guess Cu3 plus would be copper Roman numeral 3 ions. Okay. So what the Roman numeral tells us is the Roman numeral is the metal charge. Okay. So that's really important. Also know that the Roman numerals are only in the name and not the formula. Okay, and before we move on, I want to really quickly give you a list of Roman numerals in case you don't remember them or don't know them. So we have 1, so 1 plus, 2 plus, 3 plus, 4 plus, 5 plus, 6 plus, which we probably won't get to, but that's okay. So Roman numeral 1, 2, 3, 4, 5, and 6. Make sure you jot those down if you don't know them. So for naming metal cations, all you have to do is look at the periodic table. You use the name on the periodic table exactly if it comes from group 1A, 2A, or 3A. And if it's a metal not in group 1A, 2A, or 3A, you still use the name on the periodic table, but then you add a Roman numeral to show its charge. All right, so now let's talk about naming anions. Anions are the nonmetals. So anions are the nonmetals, and they have a negative charge. Okay. The name of the anion is also formed from the name of the element. So you still look up the name on the periodic table, but you drop the ending and add IDE. And this is probably sounds a little bit familiar to you. We did this with the covalent naming. So you don't change the naming, the ending of the first name, the cation, but you do change the ending of the last name, the anion. Okay, so the nonmetal name ending is dropped and IDE is added. So what kind of endings would you drop? So on, and I'll give you an example like carbon. We drop the on and we get carbide. Or ogen, like nitrogen. So we drop the ogen and we get nitride. Egen, like oxygen. We drop the egen and we get oxide. In, like, oh, I can't think of one. Let's see. Let's see if we can find an in here. Anybody see an in? Okay, not in. Sorry. So ignore this one. Orus, like phosphorus, we're going to drop the orus and have phosphide. Like sulfur, giving us sulfide. Ick, like arsenic, we're going to drop the ick and have arsenide. Eum, like selenium, we drop the eum and we have selenide. Ene, like chlorine, giving us chloride. So for the anions, let's go back. Cations, the metals, we just use the name on the periodic table if it's group 1A, 2A, or 3A, or we use the name off the periodic table and a Roman numeral if it's not group 1A, 2A, or 3A metal. We do not drop the ending. For anions, the nonmetals, we use the name off the periodic table and we drop the ending and add IDE. All right, so onward. How do we name binary ionic compounds? The name of the binary ionic compound, also known as salts, by the way, consists of two words, the name of the cation followed by the name of the anion. And one thing I want to point out really quickly is we do no prefixes. Okay, we never use prefixes like di and tri, mono. Do not use prefixes. No prefixes. All right. So let's give this a try. So remember, we're going to name the cation first, which is calcium. So let's find calcium. Sorry. Calcium is right here. He is a metal in group 2A, which means we just write his name. We just write calcium. So Ca is calcium. And Cl is our nonmetal. Cl is right here. He is chlorine. We're going to drop the ending and add IDE. So this is calcium chloride. All right, now let's try going from a name to a formula. It's very similar to what we've been doing with writing formulas before. It's just I never gave you the official name before. Well, zinc 1. It's got a Roman numeral. That means it's charge. We know it's charge. The charge on zinc is 1 plus. Why does zinc have a Roman numeral there? Well, zinc is a metal not in group 1A, 2A, or 3A. So there needed to be a Roman numeral in his name. So again, the Roman numeral tells us the charge, so we know this is Zn 1 plus. So let's try sulfide. What is sulfide? It's the last name, so we know that ending was changed. Well, let's look it up and see if we can find something with sulf. Ah, there it is. Sulfur with the ending changed. So sulfur is a nonmetal, which means it gains electrons. It needs to gain 2. So it's going to be S2. It gained electrons, so it's going to have a, whoops, no, miss more. It gained electrons, so now it's going to have a negative charge because it has extra electrons. So he's S2 minus. So Zn S2 minus. Okay, so now we have our anion and cation written, or cation and anion written side by side. They're noble-ish. Zinc isn't, but he tried. Now we need to make them neutral. So we have a total of 2 negative charges and a total of 1 positive charge, which means we need a little bit more positive charge. Let's add another zinc. Now we have a total of 2 positives and 2 negatives. So our charges cancel out, and we now have the formula Zn and S. We have 1, 2 zincs and 1 S. So there we learned how to go from the name to the formula. All right, let's try just a couple more practice problems, make sure we're comfortable with this. So we have magnesium bromide. So since I gave you the name, we must be looking for the formula. All right, so we need to look up magnesium. Magnesium is right here. It's a metal in group 1A, 2A, or 3A, specifically in group 2A. So he will become like a noble gas. Remember, they all want to be over here. So he's going to lose 1, 2 electrons to become isoelectric with neon. So if he lost 2 electrons, whoops, wrong way, sorry. He's going to be magnesium 2. He lost 2 electrons. He has extra protons, so he's going to be Mg2+. All right, now we need to look up bromide. Bromide. Remember, with the last name, we dropped the ending, so we're going to find brom something on the periodic table. So, sorry, keep going the wrong way here. Bromine. That would be bromide. He's a non-metal, so he's going to gain 1 electron to become like a noble gas. So he's going to become like krypton. So he's Br1. He gained an electron, which means he has extra electrons, which means he's going to have a negative charge. Alrighty, so now they are noble but not neutral. We have a total of 1 negative charge and 2 positive charge. So we need more negative charges. So let's put another bromine there. Now we have a total of 2 negative charges and 2 positive charges. So our charges now cancel out. And when we write the formula, we're going to have magnesium and bromide. We have 1 magnesium, so we don't write anything, and we have 2 bromines. There you go. Okay, let's try a naming problem. So we have K2S. Remember when naming, we start with the cation. The first one is the cation. And we're just going to use the name on the periodic table. So let's look up K. K is right here, and his name is potassium. So his name will be potassium. Oh, wait, he's in group 1A. He's a metal in group 1A, so no Roman numerals. And then our anion is S. S is right here. He is sulfur. So this is sulfur. But with the last name, we need to drop the ending and add IDE. So this is going to be potassium sulfide. I hope you guys are starting to get this. One last practice problem. We've got a name here, so we're going to be writing the formula, which means we got to figure out the charge and stuff. So lead, Roman numeral 4. Remember, the Roman numeral is the charge. So we already know the charge on lead. So let's find lead on the periodic table. Lead is right there, Pb. And you will note he is he's a metal not in group 1A, 2A, or 3A, which is why he has that Roman numeral. So lead is Pb, and we know his charge is IV, which is 4 plus. Metals are always positive. All right, oxide. We'll find that on the periodic table. Oxide is oxygen with his ending changed. So he's a nonmetal, which means he's going to gain electrons to become like a noble gas. He's going to gain 1, 2 electrons. So he's O2, and he gained electrons, which means he has extra negative charge. So he's going to be O2 minus. All right, they are noble-ish, but not neutral. Right now, we have a total of a 4 plus and a 2 minus. But we can add another negative, another oxygen. Now we have, sorry about that, we have 4 plus, 4 minus. Woohoo, they are neutral. So the charges cancel out. And we write our formula, PbO, with 1 Pb and 1 2 Os. All right, folks, that's it for today. Have a good one.